So yes, my voice is absolutely fine. So no problem in the voice, I think. Let's check the video also. So please share the video to all your Telegram groups, all your WhatsApp group, wherever you can find your friends, those who wants to learn the concept of random process. As we discussed yesterday, that today we are going to discuss about the random process concepts, where I will discuss about the autocorrelation and the power spectral density. Okay, so let's share it in the different Telegram groups. Yeah, so I am also sharing with all of my Telegram group. So if you have not shared it yet, please share it. And before starting the session, you should know that these crash course series which we are running here is for the GATE 2023, and here we are not actually completing the complete crash course. Here we are more focused on the important topics which is required to learn for the GATE 2023 exam point of view. So when I am seeing, yes, so many students have already been joined. Yes, Chinmay, good afternoon. Yes, Ravi, good afternoon. So today we are going to learn about the binary random process. So if you have any doubt on binary random process, then this session is for you. And if you have not liked the session, so please like the video and share the video with your friends. You can share in your WhatsApp group, Telegram group, wherever your friends are there who wants to learn the concept of random variable. You just send them. Okay, so let's start our session. Okay, let's start our session with the brief introduction. And this is nothing but this is Saket Verma, and I am having more than 12-year experience in the field of GATE and ECE. And I have done MTech from IIT Guwahati. I have created a different PSU exam as well. I teach subject electromagnetic theory, communication system, advanced communication system, and signal system as well. So these are my area of expertise. GATE AIMER'S series, as I told you, this is a crash course in which we are covering the complete important topic of the EECIN through this crash course. So if you have not subscribed the YouTube channel, so just subscribe and also press the bell button so that you will get the notification also. And there is a scholarship test going on for the GATE 2024 aspirants. So in the 24th of December, that is on Saturday, 8 p.m., you can attend the scholarship test and you can get up to the 90% scholarship, and you can register, and the link is given in the description. So GATE and ESE test series is also there. You can get unlimited access to the full length mock and subject wise test. Again, the link is given in the description. So in the test series, we are covering the 60 plus test, and we are having the detailed mock analysis where we experts are going to analyze the questions. Virtual calculator is there. This exam is curated by the GATE expert, all India mock test, so you can see your rank among your thousands of GATE aspirants, and more than 4,000 practice questions are also available. Okay, so these are the GATE and ESE test series. So here we are going to discuss. Yes, Aninday, good afternoon. So as you guys demanded for the binary random process, we are going to start the binary random process. So what is the meaning of the binary random process? See, when there is a random thing, like when there is a random sequence of data coming, then we call it as a random signal, right? जब बाइनरी आएगा, इसका मतलब क्या हो जाएगा? When the ones and zeros are coming randomly, because binary data means we say one and zero only. So ये जो वन और जीरो होंगे वो रैंडमली आ रहे होंगे, इनका कोई प्रॉपर सीक्वेंस नहीं होगा, कोई प्रॉपर फ्लो नहीं होगा, कभी भी वन आ जाएगा, कभी भी जीरो आ जाएगा. Then we will call it as a binary random process, because these binary data are appearing randomly. Now, in the binary random process, we represent the binary 1 by the positive pulse and represent the 0 by the negative pulse. So, यहाँ पे आप देख रहे हो this diagram. this is the binary 1 we are going to transmit. So when we are transmitting the binary 1, we are transmitting the positive amplitude pulse having the duration t, and when we want to transmit the binary 0, we are transmitting the negative pulse having the amplitude -1 and duration is still t. So we are transmitting 1 0 0 and 1. Okay, 1 0 1 1. So for 1 we are transmitting the positive pulse, okay, for 0 we are transmitting the negative pulse, and for 1 again we are transmitting the positive pulse, again for 1 we are transmitting the positive pulse, and each pulse is having the duration t. This amplitude can be anything. It can be +5 -5, it can be +2 -2, it can be +1 or -1. Hence in general we are saying it is plus A or minus A. Yes, we are using the non-return zero pulse here, and for the binary random process we consider the non-return zero pulse only, which is present in our syllabus. We consider only non-return zero pulse for representing the 1 and 0 in case of binary random process. Good evening, dreamers. Okay. Right, so these are the 1011, and if you are transmitting 1011, these 1011 are coming randomly. There is no sequence, there is no particular method of transmitting 1011. You can transmit any random binary data. It can be 111 000, it can be 1100 1100. This can be anything. So for whenever the binary 1 will come, we will transmit a rectangular pulse of the amplitude positive A, and whenever the binary 0 will come, we will transmit the data of having -A amplitude. Okay. Now this AK is a discrete random variable which can have the two amplitude, either plus A or minus A, with the equal probability, and this AK is nothing but we are representing it by the PT, and this rectangular pulse PT, this can, you can write it as AK also. This AK is plus A or minus A. So with the help of this PT, you can represent your random process, and this random process is x of t is equal to summation k equal to minus infinite to infinite AK pt minus kt. Right, suppose for k equal to 0, you are getting the AK as uh, plus 1. Okay, if your AK is plus 1 amplitude, then what will be your expression of xt? The expression of xt will be for k equal to 0, this is p into pt, right? Then similarly for k equal to 1, the amplitude is suppose -1, then this x of t will become p t minus capital T, right? So what is pt? The pt is here, we have already drawn. This is pt, and when I am saying t minus t, and this is minus sign because the amplitude is minus, so the amplitude will be negative. So the amplitude will be negative like this. This is -1 amplitude, this is +1 amplitude, and when you add these equation number 1 and equation number 2, then you will get this combined signal. Similarly, if you take k equal to 2, k equal to 3, then, and when you add them together, you will get the pulse we have defined earlier in the previous slide like this. So this is for k equal to 0 we are getting, this is for k equal to 1 we are getting, this is for k equal to 2 we are getting, and then this is for k equal to 3 we are getting. So when you add all those signals, all those rectangular pulse, it will be a combined signal which is called a binary random process. Okay, so how this binary random process is formed, is it clear? This P is not an impulse train. Okay, this P is not an impulse train. This is a rectangular pulse. Okay, Anindal? Yes. So Ravi, it is clear to you. Similarly, if I want to ask Dreamer and yes. Okay, so how this random binary process is formed, you can understand now. So we have said that a binary random process can be can be represented in the form of summation, which is summation over k equal to minus infinite to infinite. The amplitude is ak. This ak is a discrete random variable because it can have only two amplitudes, either plus a or minus a, and pt minus kt, which is a rectangular pulse. This rectangular pulse is having the duration t or width capital T, and this pt should be shifted either by plus t or minus t in the left and the right hand side. Depending upon the amplitude, it will take the shape, and when you add them together, the binary random process will be formed. Yes. Okay. So now there is a first case. Okay, when we take the first case, this is a case 1. There is one more condition we can take. This is the time delay. The time delay of the pulse. When we transmit the signal through the channel at the receiver, how do we detect the data? We take the sample at the end of the bit interval and we compare with the threshold, right? So let me draw one diagram for you. At the receiver, when we detect the data, this is a threshold comparator. Okay, this is a threshold comparator. We have some pre-decided threshold value and we get the received signal. Okay, here we have the received signal. Let us suppose Z of t. Okay, so we compare with the threshold. So Z of t is greater than threshold. Then we take the decision in favor of 1. And when the Z of t is less than threshold, we take decision in favor of 0. So this is how we compare with the threshold value, and hence we decide the signal is whether 1 or 0. So for that we have to take the sample which is to be compared. Sample should be taken, sample at t is equal to capital T. At every end of bit interval we take the sample. Yes, VTH you can take 0. It doesn't matter right now. We are not interested in the threshold value. We are more interested to understand that we are going to take the sample at the end of bit interval. So we are taking the sample at the end of bit interval, right? So at the end of bit interval, we will take the sample. So, because in the digital communication, the synchronization is required. So, synchronization is required means you don't want any delay while receiving the data. But suppose you are transmitting x of t and you are getting the signal which is delayed by some duration td, okay, which is delayed by some duration td, then the signal you will receive will be like this. Okay, it will be delayed. The previous signal is delayed by td and you will get this signal. And because we are going to take the sample at the end of bit interval, there is, this is the end of bit interval. Bit is terminated at t. So we will take sample here. We will take sample here because this is the end of bit interval, which is 2t. We will take sample here. So we will take the sample at this point. So when we take the sample, it is considered as positive, it is considered as negative, it is considered as positive, and we have transmitted the positive, negative, and positive. So whatever we are transmitting, we are getting the same polarity, right? At the end of the bit interval, when I see the actual signal which I have transmitted, which is x of t, I saw that at the end of bit interval it is positive, and when I am receiving the signal and the received signal is delayed by the TD second, then also at the end of bit interval I am getting the positive pulse. Okay, at the end of the bit interval for the second pulse, still I am getting the negative amplitude and still I am getting the positive amplitude for the third pulse. That means there is no error. There is no error at all. There is no error at all. Understood? So when the time delay is less than the duration of the pulse, there is no error while receiving the data. There is no error while receiving the data. Is it clear? Yes. Now, what will happen if the delay will be more than the duration of the pulse? This is the case 2. This is the case 2 when the delay is greater than the duration of the pulse. When the delay is greater than the duration of the pulse. What is happening here? You can see that this is the delay. This is the delay. TD. So your signal is received after the TD time, that is more than the duration of the pulse. So what is our procedure to detect the signal? We take the sample at the end of bit interval and that sample is compared with the threshold value. So we will take the sample at the end of bit interval, which is T. So when I take the sample at T, I am getting the negative amplitude. Okay, and this negative amplitude is compared with what? Threshold comparator, which is having the zero threshold. Which data you will receive? Which data you will receive? 0. Okay, you had transmitted 1, your first binary data was 1, but you are receiving what? 0, because the delay is greater than the duration of the pulse. What is happening? When you take the sample at the end of the bit interval, if the previous data was 0, then the delay will be such that it will be negative at the time t, capital T. At the time capital T, the pulse sample will be negative and that negative pulse will be compared with the threshold, which is 0, and then you will take decision in favor of 0, but you had transmitted 1, so the error will occur. Similarly, for this also, for 2T also, you are receiving the positive amplitude, but actually you had transmitted the negative amplitude. You had transmitted the negative amplitude, but when you are taking the sample at time t is equal to capital 2T, then time you are having the positive amplitude, and when you compare it with the positive amplitude, you will take decision in favor of 1, but you had transmitted 0. So that means error will occur in the second case. So without error, because there is a synchronization delay possible, it is our requirement in the digital communication that the perfect synchronization should be there, but there is a chance that there will be an imperfect synchronization, and if it is imperfect synchronization, then in that case the error will occur. Hence, even though there is a delay in the receiving signal, you can achieve the correct signal, but the condition is your time delay should be less than duration of the pulse. It should be less than duration of the pulse. Yes, threshold comparison is done always at the integer multiple of t, because we always take the sample at the end of bit interval. So at the end of bit interval, that means integer multiple of t only. Okay. So in this way, we are not getting the correct data. So now this delay, what should be the delay? The delay is continuous random variable which is uniformly distributed between 0 to t. As you have understood that this delay can be anywhere, but it should be less than t, and there is the equal chance of getting the delay between 0 to t, because we don't know about the delay, that what will be the exact delay. The delay can be of 1 microsecond, it can be of 2 microsecond, it can be of 1.5 microsecond. So the delay can be anything, but it should be under the capital T. So because it can take any value, it can take any value between 0 to t, and getting the value between 0 to t is equal probability, is having the equal probability. That is why they are defined as uniformly distributed random variable. So the probability density function of the delay, which is a continuous random variable, is uniformly distributed between 0 to t. Why we are taking between 0 to t? Because when it is between 0 to t, there is no error. When the delay is more than capital T, there will be an error. Hence, our overall random process, our overall binary random process will become summation k equal to minus infinite to infinite ak pt minus kt was already there. Now you have to introduce one more term which is td. Okay. Now we have to introduce one more term which is td. Is it okay? So we have two type of random variable. This AK is a discrete random variable and this TD is a continuous random variable, and this is the random process. Yes. So now we will calculate our autocorrelation and power spectral density for this random process. So let's calculate it. So if I will write, okay, this x of t, I had written ak, right? Yes. One more thing that you can see here, when I take the sample at t is equal to capital T, we are getting the positive amplitude, okay? And when I am calculating the or taking the sample after some time, okay, after some time, that means obviously 2t, after some time means at 2t we are getting the negative amplitude. So there is a chance that we can have the two different amplitude consecutive. Okay, there is a chance that we can have the two different amplitude in the consecutive pulses. So we will write this x of t equal to uh, we want to write autocorrelation now. Okay, so we will write Rx tau equal to expected value of xt and x of t plus tau. Okay, expected value of xt and then t plus tau. So now expected value xt is summation over j is equal to minus infinite to infinite a j and then p of t minus j capital T minus T D, and the second amplitude is summation k is equal to minus infinite to infinite ak p t minus k t minus T D. Is it a wide sense stationary process? Okay, if it is a wide sense stationary process or not, we can calculate the autocorrelation using this formula. And if it is a wide sense stationary, then it will automatically come as a function of time delay. And if it is not a wide sense stationary, then it will not come as a function of time delay. Okay. So wide sense stationary can be proven in the y-axis stationary random process, what is the expected value of mod x square? Mod x square, it is mean square value only, na? Summation j is equal to minus infinite to infinite. Summation k is equal to minus infinite to infinite. Aj into ak, and then this is pt minus jt minus td, and p of t plus tau. Okay, this is t plus tau is also there, na? pt plus tau minus kt minus td. This plus tau I forgot to write, I am writing here. Pt plus tau minus jt minus td. Okay. Now these aj and ak are the two different amplitudes, and this td both are independent to each other. Okay, both are independent to each other. So before that, we will take the j is equal to n plus k. Okay, let assume that j is equal to n plus k. Then what will be the expectation? This expected value of summation j is minus infinity to infinity, so n will also be minus infinity to infinity. K is already minus infinite to infinite. Aj has become n plus k, and this is ak, and pt minus nt minus kt minus td, and then p of t plus tau minus kt minus td. As I said that these two are independent, so when they are independent we can write it as, okay, we can take this summation outside. Summation n is equal to minus infinite to infinite, and then we can write expected value of a n plus k, a n plus k and ak, and then we can write summation because they are independent, so expected value of a into expected value of b, so this is expected value of summation k equal to minus infinite to infinite pt minus nt minus kt minus td, and multiplied with p t plus tau minus kt minus td. Okay, so tell me whether it is clear or not up to this point. Okay, it is hidden something. Okay, so I have written this because A and TD are independent random variable. So expected value of AB is written as expected value of A into expected value of B. So expected value of A, so I am taking expectation inside the summation. So summation n equal to minus infinite to infinite I have taken outside, and then expectation is applied to A n plus k and AK, and the k summation k equal to minus infinite to infinite is I am taking inside, and then summation, or you can change the expectation also, right? So we can take the expectation inside. So we want to calculate this, we can change now. This we can again change. So what is the first term? What is the first term? Can you tell me what is the first term? What is the first term? What is this term which is representing? What is this first term? Summation n equal to minus infinite to infinite. This is autocorrelation as a function of time delay, which is n. And then we are writing this k minus infinite to infinite outside, and we want to calculate the expected value of pt minus nt minus kt minus td, and then p of t plus tau minus kt minus td. Okay, so what I am doing is, because you have understood now, so I am writing it behind me, so that when at the end you will get the PDF, you will be able to see it clearly. Okay, yes, the first term is nothing but a autocorrelation. And now how to calculate the expectation? So to calculate the expectation, we have Rx of tau equal to summation n equal to minus infinite to infinite Ra of n. How do you calculate the summation expectation? K equal to minus infinite to infinite 0 to t p of t minus nt minus kt minus td, and p of t plus tau minus kt minus td, t plus tau minus kt minus td, and the pdf will be 1 upon t and d of td. Okay, so tell me whether this step is clear or not. This first line is clear or not? How do we calculate the mean value of any particular random variable? So mean value of random variable is nothing but an integration and over the PDF. Okay, integration. Yes, so that is what I am asking. See, and then when you want to calculate the mean value of random variable, that is expected value of x, which is a random variable, so it is nothing but the integration from minus infinite to infinite, and then the whatever written inside the expectation, you write it here, and then the PDF fx of x and dx. This is the formula to calculate the mean value, right? So here we wanted to calculate the expected value of this term, complete term, which is inside the expectation. Okay, so we want to calculate the expectation of p of t minus nt minus kt minus td into this. So same thing we have applied, whatever written inside the expectation. Yes, so this is what I have written, and the PDF is 1 upon T. This is 1 upon TD, right? The delay is, no, no, yes, T. This is 1 upon T, right? Now, let us assume that T minus KT minus TD is equal to U. Let's assume T minus KT minus TD is equal to U. So when you assume it, it will be minus TD is equal to DU. And what about the limit? When the TD is 0, the U will be T minus KT, and when the limit TD is equal to capital T, the U will be T minus KT minus T. So it can be written as T minus K plus 1 into T. T minus K plus 1 into T. Okay, so this will be Rx of tau equal to summation n equal to minus infinite to infinite RA of n and summation k equal to minus infinity to infinity, the limit from, because there is a minus sign, because of this minus sign the limit will be interchanged. So the lower limit will become upper limit, so this will be t minus kt. Okay, I am actually skipping one step, and this will be t minus k plus 1 into t, and inside the integration we have t minus nt, t minus kt minus td, so this will become u minus nt, and this will become u plus tau, and 1 upon t, and dtd is equal to du. Actually it should be minus du, but because of that minus sign the limit I have already changed. Now summation n equal to minus infinite to infinite Ra of n, when k is varying from minus infinite to infinite, the limit will also change from minus infinite to infinite, p of u minus nt and p of u plus tau and 1 upon t du. So I am taking this 1 upon t outside, and this is summation n equal to minus infinite to infinite. This is Ra of n, and this is called autocorrelation of p. So this is known as Rp tau plus nt. Why we are calling this tau plus nt? Because the time delay, you can check the difference between the time between these two function is tau plus nt. So this is the Rp tau plus nt. So this has become the autocorrelation of binary random process. So this formula you have to apply everywhere where you want to solve the question. Okay, whenever you see the binary random process, you have to apply this formula. Okay, so this is the important result we are getting. Okay, so remember that one point here. Remember that one point here is the autocorrelation that we have defined. This is Rp tau. This Rp tau is nothing but the P tau and convolve with P of complex conjugate of minus tau. Okay, and this Ra of n is expected value of A n plus k and A k. These are the two things. So tell me if you have any doubt in these steps. Because this pt is a deterministic signal, okay, this pt is a deterministic signal, so for this deterministic signal the autocorrelation calculation is done as minus infinite to infinite. It is a continuous signal and deterministic also, so we can calculate its autocorrelation by integrating it over the minus infinite to infinite. Okay, so the convolution integral we can calculate Rp tau, P tau convolve with P complex conjugate of minus tau. So this I have given. Last step again after integral. See, this is the convolution integral. So how can you write the convolution integral? So we usually write, suppose we want to convolve x of t with h of t, right? How do you write this convolution? You write minus infinite to infinite x of tau h of t plus or minus tau d tau. Okay. So similarly we have written here that we have the pt and here you can see that we have the p tau and p minus tau. So suppose you have p tau and complex conjugate of p minus tau. Okay, then how do you write? This is minus infinity to infinity. This is nothing but a p tau and p of u minus or plus tau, like that you can write. Okay, so here we have the same thing. Okay, here we have the same thing, just the delay between them is nothing but a u. Let's write t minus tau or t plus tau, whatever you want to write. Okay, so if you want to write this minus tau also, because this is p minus tau, so you can write p minus tau here, then the difference is u. So similarly, when you will write this p of u minus nt and u plus t, this will become the autocorrelation of p with the time delay, which is tau plus nt. Okay, yes. So this is the important formula for the binary random process. Now our aim is to calculate its power spectral density. So how do we calculate the power spectral density? So now the power spectral density of binary random process. Power spectral density of binary random process. Okay. Now to calculate the power spectral density, we will apply the Wiener-Khinchin relationship. So we know that from Wiener-Khinchin relationship, the autocorrelation and the power spectral density are Fourier transform pair, right? So if we have calculated the autocorrelation, then we just need to take the Fourier transform. And which function will give you the Fourier transform? Obviously, which is the function of time. So the function of time is Rp tau. Okay, the function of time is Rp tau. Ra of n is independent. So when we take the Fourier transform, this Sx of f will be 1 upon t summation n equal to minus infinite to infinite Ra of n, and then we have to take the Fourier transform of Rp tau plus nt. So as we have already said that this Rp tau is nothing but Pt or p tau convolved with p complex conjugate of minus tau. When I take the Fourier transform, I will get the Fourier transform S of f as P of f multiplied with P of f complex conjugate, or we can say that P of f mod square, right? P of f mod square we can say, because when we take the Fourier transform, the convolution will become multiplication. So this convolution will become multiplication, and the Fourier transform of P of tau is P of f, and the Fourier transform of P of complex conjugate of minus tau is P of complex conjugate of minus f, you can say. Okay, so this will be P of f mod square, and now P of f mod square, and this signal is actually not Rp tau, it is Rp tau plus nt. So Rp tau plus nt will have the Fourier transform e to the power plus j 2 pi f into nt multiplied with Fourier transform of Rp tau, which is P of f mod square. Is it clear? So from here we can write Sx of f is equal to 1 upon t summation over n equal to minus infinity to infinity Ra of n P of f mod square e to the power j 2 pi f into nt. Okay. So this is again an important relation. So in that clear, dreamer, both of you? Is it clear to both of you? Okay, great. So let's solve one question. This is the question that was asked in GATE, and now you are able to understand this question very easily. Okay, I think some part of this question has missed. Okay. Okay, read the question. I am bringing the question for you. Fine. So x of n is minus 1. Okay, I'm writing the question here. X of n is minus 1. Both are having the probability 0.5 for each n. We have to calculate expected value of y t, expected value of yt and yt minus 3t by 4. Okay, this is the gate question, and we want to find expected value of yt and yt minus 3t by 4, or you can say that autocorrelation of y at 3t by 4. Okay, we want to calculate this. Now you can see that this is very much similar to what we have studied. Okay, just the difference is we have written the random process, binary random process, in this way: summation over this n is equal to minus infinite to infinite. We have written an and then p of t minus nt minus td. So that is what we had written, but in the question it is written like yt is equal to summation n equal to minus infinity to infinity xn pt minus nt minus 5, where pt is ut minus t. So you can see that this pt is also same. This pt is a rectangular pulse having the width t and height 1. Okay, this is your pt. And ut is a unit step function. Phi is independent random variable uniformly distributed between 0 to t. So they are not saying directly as a delay term, they are saying that it is just a random variable which is uniformly between 0 to t. But we know that what is that phi? Phi is coming because of the time delay. So the sequence consists of the independent and identically distributed binary valued, and p of xn and xn equal to minus 1 is 0.5. So the amplitude is either plus 1 or minus 1, and they are equiprobable, because sometimes the plus 1 can come, sometimes minus 1 can come. So the probability of both will be same. When there are large number of data, then the probability of 1 and probability of minus 1 both are same. That is 1 by 2. Then we want to calculate autocorrelation. So according to formula that we have studied, this is Ry of n. Okay, here we have studied, sorry, Ry of tau, not n. Where is that? Ry of tau is equal to, what should be the autocorrelation? So summation n equal to minus infinite to infinite 1 upon t Ra of n. Instead of a we have Rx, so we will write Rx of n and then Rp of tau plus nt. Okay, is this definition clear? So we have compared with what we have studied in the theory. Just difference is, instead of x we used a. So when we write the formula, we have to write the autocorrelation of x instead of a, because in the question they have said xn. So you write rxn and then rp, p is same. So rp tau plus nt. Okay. Now we will calculate the Rxn. So Rxn is nothing but expected value of Xn and Xn plus k. Expected value of Xn and Xn plus k. Okay, you have to just calculate the autocorrelation first. Okay, when you calculate the autocorrelation, what will happen? When you will calculate the autocorrelation, so expected value of xn and xn plus k. So depending upon the value of k, suppose the k is 0, when the k is 0, Rx of n will become expected value of xn square. So xn square is nothing but the mean square value of xn. How do you calculate the mean square value? Because the xn is a discrete random variable, you can see that this xn is having the two value either plus 1 or minus 1 with the probability 0.5. So its mean square value will be summation over I, and we know that the xi square and probability of xi, this is how we write the formula. So the value of the random variable is minus 1 square and its probability, which is 1 by 2, that is half, and this plus 1 square and its probability, which is 1 by 2. So the answer is 1. So the autocorrelation for k equal to 0, we are getting 1. The autocorrelation for k equal to 0, we are getting 1. Okay. Now what will be the value when the k is not equal to 0? When the k is not equal to 0, we have to write Rx of n equal to expected value of xn and x of n plus k. Okay, the expected value of xn and xn plus k. Well, they are given as independent. So they are given as independent. So you can write x of n multiplied with expected value of x of n plus k. And what is expected value of x of n? This is nothing but the mean value. And how can you calculate the mean value? So expected value of x of n can be written as minus 1 into its probability and plus 1 into its probability. So it is 0. So you can say that the Rx of n, that is autocorrelation when the k is not equal to 0, will always be 0 when the k is not equal to 0. So in this way you can say that my autocorrelation, which is Rx of n, can have only two values. It can have the value 1 when the k is equal to 0, and it is having the 0 otherwise. That means k not equal to 0. So Dreamer and Aninda, is it clear? Yes. Okay. Now, if suppose they are not independent, if they are not independent, in this question they have given independent, but if they are not independent, then how to solve? Okay. If they are not independent, then how to solve? So you have to calculate the combinations x of n and x of n plus k, and the product x of n and x of n plus k and its probability. Okay. So I am telling you this, when they will not give you independent, then how to approach. So you have to make a table in which all the possible combination and their products and its probability you have to write. What are the possible combinations? The possible combinations are both can be minus 1. Okay, means x of n is minus 1 and the data which is coming is also minus 1, means consecutive two zeros can come, consecutive two zeros can come. So when the two zeros will come, for the binary 0 we will have negative amplitude, so that is minus 1 minus 1. So the product will be 1 and the probability will be 1 by 4. Okay, and then this is 0 and this can be 1, so that is minus 1 and 1, the product will be minus 1, the probability will be 1 by 4. This can be 1 and it can be 0, that is minus 1, the product will be minus 1 and probability will be 1 by 4, and both can be 1, so the product will be 1 and the probability will be 1 by 4. Correct? Okay, if they are independent, this will be the case. If they are not independent, you have to solve in this way. Now because we wanted to calculate the expectation, so expected value of x of n and x of n plus k, we have the product value. We have got the value of this product x of n and x of n plus k. Ravi, actually, they have given the plus 1 and minus 1 amplitude, so we cannot write 0. Instead of minus 1, we cannot write 0 because they have said about the amplitude which is defined as positive and negative amplitude. So you will not write binary 1 and binary 0, you will write the amplitude. In xn and xn plus k, we write the amplitude. So what is the product? The product is 1. What is the probability? 1 by 4. The product is minus 1. What is the probability? 1 by 4. The product is minus 1. What is the probability? 1 by 4. The product is 1 and probability is 1 by 4. The result is still 0. Now check. Okay. So if it is independent or not, it is coming 0 in this case, but it will not be the case every time. So you have to be careful whether they are given independent or not, and if they are giving independent, then you can just take a mean value of xn, and according to the mean value you can directly say what will be the autocorrelation, and if they will not give independent, then you can solve by this method. Whatever will be the amplitude given, according to that you have to calculate the products. Okay, it is possible that in some question it is possible that for binary 1, okay, it is possible that for binary 1 they will give you the plus 5 amplitude, and for binary 0 they will give you the 0 volt amplitude. So in that case the combination will be 5 0 and 0, okay, then 5 and 0, 0 and 5, and then 5 and 5. Okay, this will be the value, and when you multiply 3 times you will get 0, and fourth time you will get 25. Okay, so this is the case. Are you getting now? So it will be the case of unipolar. In case of unipolar, you will do the same thing. For the binary 1, you will assign some amplitude, and for binary 0, you will assign 0. And when you will assign 0, then the product you will calculate. So 3 times it will get 0, and the fourth time it will get the multiplication. P No, it is the probability of the combination. In the P of xn and xn plus k is the combination probability of the product. Probability of this product, because there are 4 possible combination and all are equiprobable. So that is why 1 by 4, 1 by 4, 1 by 4 I am writing. Okay, I am not writing as a product of xn and xn plus k. It is the probability of combined term xn and xn plus k. It is the probability of the whole product, and that whole product is having only 4 possible combination. So each is having the probability 1 by 4. Obviously, there are only two terms, 1 and minus 1, so its probability will be 1 by 2 and 1 by 2. But we can write it 1 by 4, 1 by 4, and then later on we can add them. These two should be added, and this two should be added. Right? Okay. Now, so what is our question? Again, coming back to the question, our purpose was to calculate the RxN. Okay, our purpose was to calculate Rxn for different value of n. When I will put n equal to 0, okay, let's put n equal to 0. You have seen that this Rx of n is having only two values. This is k equal to 0, not k, it is n equal to 0 and n not equal to 0. Wait. Just a small correction here. If I am writing Rx of n, the delay should be n, but the delay is k here, right? Very small correction here. Just make it this a small correction. This should be k, xk and xn plus k. Okay, so this is xk square, and this is xk. This is same. Okay, very small correction. Just for this is xk, this is for n not equal to 0, and this is xk, xn plus k, it is okay, xk, and this is also xk, xn plus k, xk, and xk. Okay, just there is a small correction because it is the autocorrelation, and when we write the autocorrelation, it should be function of time delay. So the delay here is k, right? This is n plus k and minus k. So the delay here is n. Previously I had written as n. So when I was writing x of n and x of n plus k, then the delay was n plus k minus n. That time the delay was k, but actually I am writing Rx of n. So when I am writing Rx of n, so the delay should be n. So for the delay to be n, it should be xk and xn plus k. Is it okay? Or there is any confusion? Is it okay or any confusion? Yes, okay na. So actually one small correction was there. So n equal to 0 it is 1, n not equal to 0 it is 0. So we have said that it is 1 for n equal to 0 and it is 0 for n not equal to 0. Okay. Then when we write Rx of tau, Ry of tau, which is output here, 1 upon t summation n equal to 0, n equal to minus infinity to infinity, Rx of n and Rp tau plus nt. So when I put n equal to 0, I will get 1 upon t Rx of 0 and Rp tau, right? Because when n is not equal to 0, the Rx n will be 0, so the whole term will be 0. So we will get the result only for n equal to 0. Okay, we get the value only for n equal to 0. ठीक है, क्योंकि n इक्वल टू 0 पे ही हमको Rx n की वैल्यू 1 मिलेगी और n नॉट इक्वल टू 0 पे हमको 0 मिलेगी. तो अगर मैं n की सारी वैल्यू सब्स्टिट्यूट करूं समेशन में, तो n की वैल्यू जब मैं 0 पुट करूंगा तो मुझे ये रिजल्ट मिलेगा, और जब मैं n की कोई और वैल्यू लाइक 1 2 और -1 और -2 पुट करूंगा तो वहां पे Rx n की वैल्यू 0 हो जाएगी और प्रोडक्ट जो है वो कंप्लीटली 0 हो जाएगा. सो यहाँ पे मेरे पास रिजल्ट ये आ गया. अब मेरे पास एम है Rx0 की वैल्यू मैं 1 निकाल चुका हूं, Rx0 की वैल्यू मैं 1 निकाल चुका हूं. अब मेरे पास एम है Rp टाउ की वैल्यू निकालना. तो Rp टाउ क्या होता है? सो द Rp टाउ इज नथिंग बट द कन्वोल्यूशन ऑफ Pt एंड Pt. ओके, the Rp tau is nothing but the convolution of Pt and Pt. Because this is the real signal, so this is P tau, okay, and 1 and 0 to t, and this is again 1 and 0 to t. This is P of minus tau, P of tau complex conjugate. This is P of tau, so we have to draw the P of minus tau, right? So let's draw the P of minus tau. Okay, so I'm skipping one step actually, because this is the real signal. So when you take the complex conjugate, there will be no effect. Okay, see, this you can understand from here. Here in the right hand side you can see Rp tau. Rp tau I have written as P tau convolved with P complex conjugate of minus tau. So P tau we can draw. Okay, the P tau we can draw, and P minus tau complex conjugate also we can draw. So this is the P tau. Okay, and this is P minus tau complex conjugate. Because the signal is real, there is no change if we take the complex conjugate, and when we convolve, what we get? When we convolve it, what will you get? You will get minus t, 0 and capital T, and the height is 1. Oh, sorry, height is t. Height is t. Okay, is it okay? First of all, tell me this autocorrelation is okay. Then we have got this. So at 3t by 4 we want to calculate. So what is the value at 3t by 4? What will be the value at 3t by 4? Rp tau at 3t by 4 y is equal to mx plus c. The slope is minus 1. Okay, minus tau plus intersection is at capital T. So when you want to calculate Rp 3t by 4, you will get the value minus 3t by 4 plus t, which is nothing but a t by 4. So the value you are getting is t by 4. Okay. So this value is t upon 4. Yes, in the deterministic signal continuous time, the autocorrelation is the convolution of the signal and its reverse signal, right? Reverse version, right? You are saying correctly, Anindya. Okay, when they are deterministic and real, then you can calculate by this value. So now you have got the value as t upon 4. You have got the Rp tau as t upon 4 at 3t by 4. So we are calculating the autocorrelation at 3t by 4. So we will get as 1 by 4, which is 0.25. Okay, are you getting now? So, Ravi, you were asking that Rx of n is equal to 1 and 0. For n equal to 0, when you will put the value of n in this summation, when you put n equal to 0, you will get Rx 0. Rx 0 is having the value 1. So, this 1 is multiplied with Rp tau plus Nt, so you will get this value. Okay, because n is also 0, so Rp tau. When you put other value of n, like when you put n equal to minus 1, you will get the 0 value. So this 0 will be multiplied with Rp, so that will be 0. When you put n equal to plus 1 from the summation, then this will become Rx1, and the value of Rx1 from the above relation, it is 0. So again it is 0. Hence all the other values of n will give you the 0 result other than n equal to 0. So when you put n equal to 0, you will get the value, and hence when you put Rx 0, that is equal to 1 from the above relation, and Rp tau after getting the after getting this convolution signal, we got the at 3t by 4, we are having t by 4, so we get 0.25. X is replaced by xn. X is not replaced. Okay, you can check this later on. I am not replacing x. I am not replacing x. Okay, I am just saying that the autocorrelation function we defined earlier was RA of n, right? And RA of n is nothing but the expected value of AK and AN plus K. So the time delay should be n, and that will go inside the argument. So if I am writing Rx of n, then it should be expected value of x of k and x of n plus k, because the time delay between them should be inside the argument. Okay, this n is nothing but the time delay, which is t2 minus t1. So this t2 is n plus k and t1 is k. So this k and k will get cancelled. So the delay will be n, and that delay will go inside the argument. Okay, are you getting now? So the time delay should go inside the bracket. So what is the time delay? The time delay is t2 minus t1, that I have calculated here. Okay. So binary random process is clear. So this is it for the today's session, and tomorrow we will understand some concept of band pass sampling and the quantization if time permits. Okay, so we will be discussing about the band pass sampling tomorrow. and I will try to cover the quantization if the time permits. Yes, Dreamer, PYQ session is there on communication. It will happen. PYQ series. PYQ is on 23rd December at 9 p.m. 23rd December 9 p.m. PYQ series is there 23rd December 9 p.m. 23rd December 9 p.m. Yes, I will try to catch it non-uniform quantization. Okay, and in that I will try that. So band pass sampling and non-uniform quantization. We will try to cover it. Okay. Okay, so this is the new series which is coming in, which is running in our GATE app, BYJU'S Exam Prep app, and which is GATE 24 Fundamental series and GATE 23 Rank Booster series. So you can tell your juniors to download the app, and they can get benefited by this Fundamental series, right? So please convey your message to your juniors also, and there is a free ebook where the link is given in the description. You can go and check, and that ebook you can use. Okay, so thank you for watching this session, and we will meet tomorrow at the same time 4 p.m. and we will be learning the concept of bandpass sampling, and we'll try to cover the non-uniform quantization as well. Thank you.